Welcome to the State of Developer Education, a podcast by Major League Hacking. We explore how technical leaders are creatively tackling the developer education gap to help prepare the next generation of technologists for the real world and build businesses that can adapt to any changes in the technology ecosystem. I'm your host, John Gottfried. Welcome back, everyone, to the State of Developer Education. I'm so excited for this week's episode with Jacob Marks, who is a machine learning engineer and developer evangelist at Voxel51. How are you doing today?
I'm doing well. Thank you so much for having me, John.
Yeah, thank you for joining us. So the question I start with for all of my guests is origin stories. I know from reading your background that you had kind of a zigzaggy path into this world of developer evangelism. But, how did you get your start with, I suppose for you, science and also coding?
Absolutely. So, as you mentioned, my path is, I would say, somewhat untraditional to coding and developer relations more broadly. My background is actually in physics. So I studied physics and math in undergrad, and I did a Ph.D. after that, studying things that were fairly unrelated to computer science and to the day-to-day workings of a developer. But I did get exposure to a few things that shaped the way that I moved going forward. One of those was during my PhD, in order to do the research that I was doing, I did have to run some simulations. So I got some experience programming in scientific like simulations and all that type of stuff, which turned out to only be a part of the puzzle. When I actually got into developing a little bit more and having that be my job, I realized that there's so much that you don't get to when you are focusing on the simulations and just getting a result out at the end of the day and not thinking about building a robust system that other people could interact with, moving pieces and versions and all of that. But nonetheless, the algorithmic challenges and the ways that got my brain thinking were really intriguing to me. And then the other piece of it is I also have always loved to not just be fully technical, but to have this educative and more interpersonal aspect to my work. That's something that I have been passionate about for a long time. When I was in high school and undergrad, I did some teaching as well. So in college, I did what's called Splash. I'm not sure if many people might have heard of that, but it's a program that a lot of colleges around the country have where you can go and teach people from underprivileged backgrounds. They basically have classes that you get to choose what you talk about, and you get to make the curriculum and do this a couple times a year. So I got to talk about everything from the mathematics and the physics underlying music to some more advanced physics and math topics. I even did something on science journalism when I was there, and that's really been important to me for a long time. And having this avenue to not just do the programming, but to communicate that to people and to interact with the community more has been really exciting to me. And I would say that's kind of what drove me to this path.
Yeah, that's fantastic. It's funny, like a lot of the people I talked to ended up as coders as a means to an end to achieve something else, which I think is really fascinating because people talk all the time about like coding becoming this universal skill that everyone is going to learn, in K-12. And, like there's a lot of universal skills. Like I learned algebra. I don't use it every day, but coding has this ability to sort of enable a lot of other disciplines in a unique way. And it sounds like that's kind of a big part of your story too, is that, you started using it in a utilitarian way for your physics studies, and now you're actually like working at a tech company helping other people build their own software. I'm curious, like having come from this hard science background and sort of starting out with coding as a means to an end, what are some of the unexpected differences of how developers interact with the world and how scientists might interact with the world?
That is a great question. So the first thing that I learned the hard way when I got into developing as a developer and not as a scientist is that the way that people approach the rigor of edge cases is much different in the development world. So in science, oftentimes it's about proof of concept. It's about showing that something works. It's about testing out an idea, uh, getting enough data to back up your claim, and then presenting that to people and thinking about how that generalizes and what extensions of this are and how you could potentially collaborate with people to probe deeper into things. It's not about necessarily handling every single edge case that there could be and making sure that people could interact with it in a controllable fashion. People don't really think about everything from the commenting their code and writing reusable, reproducible code so much and making the data accessible. Although there's more of an effort towards that these days, but I would say even beyond that, it's about thinking about how other people are going to be enabled by what you are doing, not just how you can get it out there for the world to see, but how you can actually build something that is useful and other people can build off of.
So if you're doing a physics project that has a piece of code, it only really needs to be reproducible like you and the other researchers you're working with directly.
Exactly. And everything you do on top of that is an added bonus. So if you create a library that other people can use, it doesn't even need to be that general. That's considered like this great addition to your project. It's not really considered in the publication process. So the actual publication and the review process is very much about the science that you do, and you may not even include a link to the package in the actual paper. But if you are trying to do the bare minimum, you don't even necessarily need to put the data out there. But if you do want it to be reproducible, then you just need to put it out there in a way that somebody can run the exact script that you did and get the exact result. It's not so much about this is a general way to do these types of things. These are the things you might want to do. I'm going to talk to people in the community, figure out what they are interested in, and how I can actually support those things and work with them to make those possible.
That's fascinating. We're kind of coming full circle here, but you're talking about that in the context of physics research. But for a long time, that was really how I thought about machine learning as well, was that there were these PhDs off in a corner doing all of this really interesting machine learning research that sometimes it took a great deal of expertise to replicate or even understand. And it feels like now, and I know that Voxel51 are a big part of this, right? It feels like now it's starting to become abstracted and generalized in such a way that developers of many different skill levels can interact with some of these models and training mechanisms and developer tools. I'm curious, what you've seen there, with that cross section of, I imagine you interact with both the machine learning researchers and also, developers, which in my mind might be someone building a web app or someone building a utility somewhere.
Yeah, there are definitely a couple of different. It's hard to distinctly categorize people into one of a few buckets, but the way that I like to think about it is there's the researchers who are trying to publish their papers. There's the hobbyists who are doing side projects that they think are cool. There's the people who are building for startups or enterprise companies that are doing this as their job and trying to build systems that are technology that other people can use or go into some final project or product that is deployed. And we interact with all these types of people through our work. Those interactions are all different. That people all want distinct things, I would say. But I think that the democratization of a lot of this developer tooling and the fact that so much has been open sourced on the data side, on the model side, in everything from GitHub Copilot to ChatGPT to the fact that now you can even fine tune your own large language model without really needing to know too much machine learning. You still need to know enough to actually understand what data you want to actually use the fine tuning for and what the quantization level you want to go to is, and you want to make sure that you don't run out of memory on your GPU and all this type of stuff. But it's a lot easier than it once was to do these types of things and to build systems that 2 years ago would have been unthinkable for most people, and now it's totally accessible to a wide swath.
That's really cool. When you're building all of these sort of different resources for people in your developer community, how do you make sure that you have content that's accessible to all of those different personas, right? Because maybe you're lucky, you're a unicorn, right? You have the science background, you have the development background, you can bring those together. I feel like the average person writing docs wouldn't necessarily know how to speak to every audience.
I would certainly not say that I'm a unicorn. I think that the skills that I have, many other people have, but your point is definitely valid that writing documentation and good material and good content surrounding the tooling that you have is essential, and that is something that far too often is definitely pushed aside and not thought about enough by the team that is actually building that stuff. We try to address this in a couple of ways. We think a lot about our documentation on the website, how it's laid out, how we actually present individual ideas, the way that we interconnect things. We also have a blog both on our website, and then we also cross post to Medium and LinkedIn, where we try to have a little bit of a higher level discussion about these things. We do video content, which is even more accessible to many people, and we try to have these different levels of technical depth that you can go down. So oftentimes people start with a video, and then they go to the blog, and then they go to the Jupyter Notebook where they are running things themselves, and then they go to the documentation from there. We've also tried to build a couple of tools to make this even easier to accelerate the on-ramp. So for instance, we built a documentation search tool that allows people to semantically find what they want in our documentation, because we understand that it is difficult to peruse through a million lines of code, and the documentation for that, even the API, can get really, really extensive over time. So we built a documentation search tool that not just shows them the relevant sections, but actually links back to those so they can go and poke around there. We built a chat bot that they can ask questions and can answer. It has access to our documentation, and they can give them the answers based on that, and can even write their queries for them. So again, it's not perfect because it's very hard to outsource the entire process of basically filtering and finding subsets of computer vision data sets to a large language model, but you can definitely handle the majority of the simple cases pretty easily. And so we've tried to do that, and not just do that in a way that, like, here's the result, but in a way that shows them the thought process that the model is going through in a way that we've constructed to make it more accessible to people who are just getting started.
I want to hear more about that chatbot, because a lot of conversations I've had recently with people who are doing like docs work or DevRel work come back to this idea that like a custom GPT trained on your docs is aspirational for some of these teams. And I haven't seen many in production that people can actually touch and use. How did you all actually build that? Like, what's the technical sort of like stack that chatbot is built on, if you're able to share that?
This actually is in production, and you can go try it out for free at try.51.ai. This has been in production for the last 6 months. We built this before OpenAI even had function calling. And we built this using, believe it or not, GPT 3.5, because we're an open source project, and a lot of people who want to run this locally, who want to use their own OpenAI API key, don't want to spend a lot of money. And oftentimes, if you're passing in tons of context about the schema of the dataset and about the documentation and doing a multi-step prompting chain, then it can add up pretty quickly. So we found that the costs for GPT-4, especially at the time, and the costs have come down a little bit now, but even now they can be somewhat prohibitive for the hobbyists and the solo developers out there. A company can probably afford these types of things, but for the open source users, we wanted to make it very accessible. So we did that. So when we were building what we call Voxel GPT, that's the chatbot for Voxel51's tool 51. The way we approach it is starting really, really small and just testing out the model on the basic cases and trying to get more and more sophisticated over time. So we have an interface. We have an API for running queries on your data. This is what we call the 51 query language. And there's lots of different methods that you can use on your data set. You can get views that match certain conditions or filter based on this or that. And there's just so much that you can do. We started out with the simplest ones. So we tried to make the model reproduce from a few shot examples that we passed in as context. And we were like, okay, if it has these patterns, can it match this type of pattern at the end of the day? We built a unit testing system to actually test this out. And of course, there's multiple ways to produce the same filtered subset of your data. There's multiple expressions that can have the same result. So you have to test not just is the exact expression the same, but is the result, is the view at the end of the day the same? And you want to test it on multiple data sets because the results you can get on different data sets are different. So we started by doing that. I'm taking this evaluation-based approach, somewhat of the like the vibe check, but also much more data centric and actually evaluation heavy. And as we were doing that, we started to add in complexity. So we wanted to add in more view stages, so the more queries, more methods, and give it more context on the data set. And we very quickly ran into issues with the context length. Of course, this is at the time when there was an 8K context length. Now it's much larger, but we realized that we needed to take a different approach. We tried to use these models to actually compress all of the information in the documentation while retaining the actual essential knowledge there and pass that in, but that still was not enough. So then we started to use an approach where we did essentially RAG before RAG was a thing. So we had a system where we embedded all of the documentation. We embedded a bunch of examples, which we handcrafted. So we had a set of about 1,000 examples that we handcrafted for various different methods that you might want to run. And from there, we were able to pass the most relevant examples in and to get the result out at the end of the day. The biggest issues that we run into here are that one, so like the underlying language model we were using, the GPT-3.5, had some knowledge of 51, but its knowledge of 51 was incomplete because of its cutoff date. So it would only ever give answers that it knew from its knowledge base of the world, from its training, not things that even we would say, like, you must do this. You have to give an answer this when you get this type of input. It would not do that. So we actually had to do a bunch of post-processing and correction and figure out the right way to kind of trick the model into doing what we wanted it to do. And that was, a really interesting process and an interesting challenge in trying to reformulate things in a way that changed the language enough to make the model think it was performing some basic pattern recognition task, and then abstract from that to our actual our use case and turn that into executable code. Suffice to say, there were a lot of challenges along the way, a lot of prompting. It was very experimentation heavy, but the gist of it is that we started small. We added complexity as we went, and it was very much not just about does this look right? This kind of looks right. Or we tried something and it didn't work, but every step of the way testing what we were doing and seeing if it resulted in improvement or not.
That is so fascinating. I feel like, and I know it's open source, but I feel like that is a product in itself. Like documentation GPTs it's such an interesting space because it can reduce support inquiries. It can make someone more efficient as a developer. It can help with customer adoption of specific features. It can just be a better developer experience in general. It really feels like there's a lot there. And when I think about the implications of that for someone who's actually learning to code, or in our world, building apps for the first time, it becomes really, really interesting, because then it's not even about specific developer platforms. It could be about you have a GPT for the textbook you're using in class that understands all of the context and lessons and where you're at in the journey. And, I can only imagine that a lot of educational products are going to be moving in that direction to be more personalized and specific. Have you seen any changes from having this live in how developers interact with your docs or even your team, now that they have this utility?
Yeah, absolutely. So I would say that the people who are on the core engineering team are typically interacting with the query language so much that they don't need to reference it. But there are other people at our company who were involved at the very early stages of the formation of the query language, who have either been away from it for a couple of months or they haven't actually been coding for a little while, or things have changed a little bit since they used it, and they don't necessarily know all of the arguments that you can pass into certain methods now, or there's new methods that exist. They use it in order to figure out what to actually write for their code. So it's incredibly useful even for people on like the team that actually runs 51. Not to mention a lot of our users, open source and enterprise. I think we definitely have seen that with this new like OpenAI customizable GPTs, the accessibility for documentation search has changed. So the way that we were using this approach to make our documentation searchable is now kind of democratized. Like everybody can do that, which is great. I think that everybody should be able to make pretty much any set of documents searchable and interactive as they'd like. And one of our community members actually just made her own. She called it Voxy. It's a custom GPT for the 51 docs, and it's really interesting to see how that compares to our approach, which was very much like boutique tailored. Like we parsed the documentation and chunked it in certain ways depending on what type of file it was, and decided what embedding model to use and how we wanted to actually rank all the results at the end of the day and spit that back to the user. Whereas the GPT bot that she made is very much like you give the docs and then OpenAI does its thing. And it's really interesting to see the differences, like automatic essentially approach to the approach that we had, which is the GPT-4 that's underlying her GPT is it's more powerful than the GPT 3.5 model for sure. There's no question about that. But the actual results that are gotten from the documentation, they depend a lot on the embedding model and the way you're chunking things. And that's something that we're seeing a lot of thought put into these days. As for the querying of your actual data set, I think that's still a pretty hard problem. And I know that there's a lot of things like text to SQL, and there's a lot of these like APIs, like if you've heard of Gorilla LLM and these other things, which try to like make 1,000 APIs accessible as tools to a large language model and function calling, and not just for GPT-4, but for other LLMs as well. That's great. I think that still has limited applicability, and we're still figuring out the right way to actually apply these things in production contexts for more complicated situations. And I'm excited to see where that goes.
Yeah, that's really cool. Let's switch gears a little bit. I'd love to hear more about computer vision specifically, because I know that's really the area of focus for 51's product, right? Most people, I think, would probably have interacted with something like OpenCV, or perhaps more recently, they're playing with like Dolly or something like fun that generates images. I know that you all are more focused on the analysis and sort of like tagging and that kind of thing. Have you seen like major changes as a result of this sort of like increased interest and investment in AI over the last year in your own community and product?
I think it's a mixed bag. If you look at the hype, it's through the roof. And I think like AI as a whole has just seen this massive revolution. Some might even call it paradigm shifting. And we know that like ChatGPT got 100 million users in like a week or something like that. Dolly is really cool. Stable Diffusion, Midjourney, these tools are really cool. And there's a lot of very interesting and like showy demos that people do. I know that there's also been a lot of talk about multimodal stuff recently, and I think that we are going in that direction. But I think that a lot of the work that is happening in this multimodal context right now is riding the coattails of the LLM wave. It's like, how can we use LLMs to do better computer vision, or how can we adapt the LLMs for also understanding vision? And those are incredible advances, and they allow for this multimodal understanding. So if you look at a lot of these multimodal data sets, like Science QA, for instance, you can see the models are getting better and better and better. They're approaching like human level performance on a lot of these things, which is tremendous. I think that if you look at the real world value proposition for a lot of computer vision tasks, and when I say computer vision, I'm talking about the more fundamental tasks of image classification, object detection, and things like even multimodal tasks like visual question answering and like referring expression comprehension. These are tasks that are still a little bit, I would say, more fundamental, and sometimes LLMs can help with, but oftentimes not. We are seeing a lot of advances in the basic computer vision work as well. So there are definitely new state-of-the-art detection models and classification models and things like that. But for the most part, what we're seeing, people who are actually doing computer vision, who are like making products and packaging things is that they care about efficiency, and they care about having a model that works well for their data. So they oftentimes want to make a special purpose model that is really, really good on their data and small enough to fit on a device that is running, with this latency. And sure, the things that are going on in the space in general are cool, but and maybe that gives them inspiration, and maybe they play around with those things. People love to play around with the new hot thing, but oftentimes the LLM hype doesn't translate into real business value for like, the pure computer vision applications.
That makes a lot of sense. I mean, it's perhaps a layer deeper on the actual like math and science of and analyzing images, right? Like, because ultimately, like even something like OpenAI, if you feed an image in and ask it to analyze it, it's using some kind of computer vision model on the back end to actually figure that out. So the foundational model has to improve.
Yeah, yeah, and I do think that there will be some knock-on effects for computer vision. Like I think that synthetic data, with Dolly and Stable Diffusion, these things they make cool artwork. It can look like photos. They can look like images that you can add to your data set, but they're not. Those specific models are not as much being used to generate synthetic data that allows you to augment your data set. People are doing work that is using these new model architectures to generate and augment their data sets and then to train better models based on that. That is work that is happening. And some of that work is very cutting edge, that is like research that is still ongoing at the top research labs. And some of it is like pretty well known right now and is just a layer more complicated than using implementations to do rotations and shifts and things like that. But that is certainly one area where we're seeing a lot of business value potential created.
That's cool. Can you tell the difference between chihuahuas and blueberry muffins yet?
uh, you know, I'm colorblind, so maybe I'm not the best person to ask about any of this stuff, but I think these models it is still funny to see those types of things.
Yeah. In your work as developer evangelist, right, and coming from a background that was a little bit different, but had roots in actually teaching and being an educator, what are some of the things that you've taken from that like classroom environment and brought to your work now, working with a larger community of developers?
We do workshops, and I think that the closest analogy to the work that I did in Splash and Sprout and those like on campus programs to bring teaching to underprivileged communities, as well as the TAing that I did during the PhD. I think workshops is definitely the closest analog, and we put a lot of thought into how we actually run those workshops, making them interactive, because we know that people are not going to be engaged by just a bunch of slides and that being it. We even add like questions that like pop quizzes into them, and we try to make it something that has a bunch of like gotchas and basically things to keep people excited and to keep their attention. We know people have very short attention spans. Uh, we also try to focus a lot on making things actually practicable. So not just saying this is the architecture and this is why 51 exists and this is how things work under the hood, but being like, okay, we built it like this because of this. Like this is a problem that you would face. So focusing more on the more like tangible like impact of something is certainly a lesson that I have learned from my days in teaching. You need to get people excited because it matters to them, and not because it's necessarily intellectually an important distinction. People will always be interested in the intellectual stuff, but if somebody's going to walk away from your workshop or your webinar with one takeaway, it's going to be, I need this for my problem. And so if you start with the problem and you then work towards a solution, as opposed to being like, this is why we do what we do, and here are some applications of that. It's a huge difference in how people perceive it and the way that they're engaged with you during and after the workshop.
Yeah, I feel like a lot of times people who are highly technical can get caught up in the details of how something works without necessarily focusing enough on the implications of what you're going to be able to achieve with it. And it's definitely something that I think more senior engineers really struggle with a lot of the time. I know that you've sort of been honing your own coding skills, right? Um, What are some of the like resources that you've leaned on really heavily in that pursuit?
I think there are two main lessons that I've learned in my journey. Um, One of them is that you need to be building projects and working on problems that interest you, either problems that plague you specifically, um, or problems that you just can't stop thinking about. And that is the best way to learn about new frameworks or new technologies or whatever else. And so a lot of the time, it's in the context of building projects because I am excited about something or I can't stop thinking about it that I check out resources at towards data science or at analytics video or one of these other sites or OpenCV. There's so many resources. Hugging Face has incredible resources these days, which I go to all the time when I'm looking at diffusers and transformers, things like that. But I would say that the biggest takeaway from like resources and where to go with these things is there's so many resources out there. There's textbooks, there's blogs, there's Substacks, there's everything you can possibly think of, videos, but just consuming stuff is not going to necessarily help you. And finding the right particular piece of content that speaks to you for what you are specifically interested in then is maybe more impactful than just doing like I need to high level learn this skill and I need to high level learn this framework. And okay, now I feel like I know kind of what that is and I can then maybe apply that in the future. So that would be the first takeaway that I would have in terms of resources for my own learning. I would say the second one is people. People are an incredible resource. And I don't mean this in like a scheming way. I mean this in just like the most genuine, like heartfelt way possible, that people who have been working in a field and who have done this before are the best resource you can possibly think of for your own education. So oftentimes when I'm building something, I get feedback from our more senior developers or from our CTO directly on something. Of course, you don't want to take people's time if you don't need it, but if you are talking to or have some communication, some bridge to somebody who is more expert than you in something, even if they're only a year or 6 months more expert than you in that thing, then you can use them when you need to in order to learn some of the subtleties of something without needing to necessarily spend days and weeks bashing your head against the wall on something. And if you don't even have access to those people in your network right now, going to hackathons is a great way to do that. So you can when you're at the hackathon, meet other people who are passionate about coding, and also the people who are running the hackathon are probably going to be more advanced in the particular frameworks or the ideas that are talked about there, and contributing to open source projects because you get a lot of feedback on the PRs that you submit or issues that you submit or whatever else it is. You get tons of feedback from people who have thought a lot about that particular framework or ecosystem or library.
Yeah, I completely agree. I mean, I remember my first engineering job. I was like 18 or 19 years old, and I was constantly asking questions to my manager, like about every design choice and library and, whatever. And luckily, he was really receptive to it, but it was just an incredible way to like learn really quickly because I was both building features and also learning the thought process that went into that, at the same time. I'm curious, like, you said that you use projects really heavily as a way to learn, right? Or to force yourself to learn. Um, what's the most recent project that you've built that really like stretched your abilities?
I feel like I'm working on like 5 projects at once right now, so it's hard to pick. But the most recent one that really drove me nuts, I would say, is a project which should be coming out very soon, which is, believe it or not, on emojis. So emojis, at least the way that I like to think about them, are a very interesting intersection and middle ground between text and images. So like the term emoji itself is kind of like it's like a pictograph. It's like image and text or character put together. So if you try to analyze emojis using pure text language models, you get an incomplete understanding. And if you try to understand them and throw image-based models at them, even if you were to blow up the little base 64 encodings of the little icons into full-size images, you're still going to get an incomplete understanding. So trying to combine those text and image interpretations of these emojis, and then really pushing the boundaries of what I thought about in terms of re-ranking was a really interesting experience. And that project will be coming out soon. So if people are interested, they will be able to access that soon. Of course, open source, because everything I do is open source.
That's awesome. Will it help me understand the text messages I get from my like Gen Z cousin?
Maybe. I don't know the answer to that, but it will certainly help you to find the emoji that you want to express a certain emotion.
Right. That's really cool. Awesome. This has been a great conversation. I feel like this is fascinating. We can go on for quite a while here. The question I like to end on for all of my guests here is if there's any kind of like aspirational figure in science or tech that you wish you could just like grab an hour of their time, get lunch with them, and like pick their brain about the world.
For a long time, I would have probably said somebody in physics. But now that I'm more in the machine learning world, the person that I think I look to as an inspiration the most is Andrej Karpathy, who is very, very deeply technically grounded, who has the research background, not just in his education, but also in the fundamental contributions he's made to the field, but who takes so much time out of his days and weeks to actually educate people on the core foundational ideas. So if you haven't checked out his videos on transformers, I would highly encourage you to do so, everybody in the audience, because they are, I would strongly consider, the best introduction to how a transformer actually works and how to build a GPT-like model from scratch. And that's just one of the things that he's done. He's also done a couple of other things, and I have no doubt that he will do more in the future. But that the ability to stay at the forefront technically of where we actually are as an AI community, and also to be able to express the fundamental ideas of those technologies to such a wide audience at the same time is really inspirational.
That's awesome. I actually was not familiar with him before, so I'll have to check him out and include some links to his work and his talks there. Thank you so much, Jacob. I really appreciate your time and everything you've shared today. I hope everyone enjoyed listening. Definitely check out the show notes for links to the cool stuff going on over at 51, and definitely subscribe for more. So thanks everyone, and happy hacking.
And thank you so much for having me, John.
The State of Developer Education is brought to you by Major League Hacking. To find out more about Major League Hacking and how we're educating the next generation of developers and helping the world's leading companies reach them, visit sponsor.mlh.io. And make sure to search for Developer Education in Apple Podcasts, Spotify, Google Podcasts, or anywhere else you listen, and click like and subscribe so that you don't miss any future episodes. And if you like it, please don't forget to leave a review, and we'll give you a shout out on a future podcast. On behalf of the team here at Major League Hacking, thanks for listening and helping us empower the next generation of technologists. Happy hacking!